Okay, today's topic, 3D graphics, user interface, and 3D Max, Mentalei. Here I list up what to do today. We're going to have a lecture, 3D Max design and renderers from the last week. But actually, we need to get to know some geometric modeling issues. So today's lecture going to be some geometric modeling. Before doing that, we need to review some user interface issues, okay? And then in the lab exercise hours, we will review some Mentalei features, sky, object primitives, and today we're going to learn some lightings, okay, artificial lights, and some more options. And the last lab exercise is going to request you to model a table, okay, some your own defined universe, so that we can generate something else using 3D Max and renderers, okay? Before handling some geometric issues in 3D Max, we need to pay attention to some user interface issues, okay? This is 3D Max Design 2015. We are mainly dealing with in this semester. But 2016 version will be released soon in 6 months, early next year, okay? And also 2014, 2013, or even totally different tools such as Rhino, Blender, or some other 3D graphics tool, or your familiar SketchUp. They all some so-called 3D graphics tool. So this is a snapshot of 3D Max. This is 2011 version, and this is 2015 version. Most people in general, when they open this kind of software, they are stunned and kind of stuck because of too complicated interface. This is not Word file, just simple image viewer or not web browser. It's really domain specific and professional software. Very hard to learn. So why this kind of software is hard to learn? I would like to bring your attention again on the GUI, your computing interface issues. You know the menu system, right? Icons, toolbars. If you click this kind of blank document icon, it's supposed to be blank document. Or this save icon, that's going to be saving your file. And nowadays we have and very features of icons, toolbars, ribbon interface, and so on. Anyway, they are all so-called GUI. Typing, clicking mouse, drag and drop, your keyboard interaction. So you need to use keyboard and mouse. Keyboard and mouse, especially on 2D plane. What's 2D plane? Your desk, okay? Keyboard, of course, it's working on your desktop. Your mouse on your mouse pad on your table or 2D. You are not moving your mouse on the air, right? Anyway, we can classify 3 different types of interface, CLI, GUI, NUI. Here are the definitions and formal description about those 3 different interfaces. Actually, you know GUI because every day in your daily life you use web browsers, accessing Facebook. They are all GUI based. How about NUI, natural user interface, by touch, motion, voice. You can control your screen by touching your smartphone, tablet, computer, and sometimes your motion can be recognized and voice recognition, such as Siri in iPhone, right? Voice recognition. Or natural user interface, NUI. In your daily life, probably you guys are playing with your computers using NUI rather than GUI. But actually, in professional computing, we need to use GUI, of course, and sometimes CLI. General software we use today, your environment, mostly in GUI or NUI. But actually, computer graphics software for efficiency and precision drawing purpose, we have to use CLI partially. You have to type numbers. What if you want to make ceiling height 2.4 meter, 2,400 millimeter, and then you have to type it. By touching or motion, it's not easy to make some precision. Okay? And in AutoCAD, you have to type rectangle, line, multi-line, and so on, so that you can efficiently draw very precisely made geometry, okay? But in reality, this yellow background, NUI, GUI, that's in your daily life interface. What is the ideal interface for making 3D geometry? What if you want to create 3D box? You can move your hand in this way, and then 3D geometry will be created on your computer. That's the easiest way, right? Some gesture recognition, or something beyond keyboard and mouse. Another advanced one is 3D laser scanning. There is a box, and laser scan device can generate 3D box geometry in automation from real world objects, okay? So NUI is a certain type of ideal interface for 3D modeling in general, but you are in architecture, especially in interior architecture design. We need to follow human scale in precise dimension, okay? No one roughly design your furniture or interior finish or wall height thickness. We have to put very precise numbers in millimeters, okay? 250 millimeters for wall thickness and so on. So actually, that is why most 3D graphics tools adapt GUI, partially command line interface. Handling 3D objects on the screen. This screen is 2D, right? It's not virtual reality environment, just 2D. But imagine there is a box in 3D. That is, we have to rotate, zooming in and out, make top view, front view, left view, and so on. Physically, it's in 2D, but we assume that is 3D. And it's actually 3D in mathematical definition. Anyway, controlling 3D objects using 2D screen by using 2D mouse control, okay? Some discrepancies. And to complicate 3D modeling on 2D views, we have to control top view, front view, elevation view, perspective view. 3 or 4 different views we need to control precisely. Too many icons, that's the limitation of GUI. Too many functions in general in 3D graphics, such as 3D Max, because there are too many functions, right? So SketchUp determined shrinking their number of icons. That is why SketchUp is kind of easy to use software, even if it's in 3D graphics. But in general, 3D graphics software is really, really complicated because there are too many functions behind. So this is reality, and this is kind of ideal. This gap, this discrepancy makes you hard to learn 3D graphics, okay? So how to overcome this discrepancy? How to overcome this gap? How to learn your software quickly? I would like to show you some ideal way or something future in this semester. I would like to bring your attention to something interesting things first, and then I'm going to tell you why it's hard to learn. And I would like to let you know how to overcome, how to learn that kind of 3D software in easier way, faster way. Firstly, we need something beyond the keyboard and mouse. iSphere, take a look at iSphere. That is kind of soft object, but you can pull or push that object and Wi-Fi connected device will automatically command that shape, and you can control that shape by handling that object, that iSphere object. Or cave. Using that goggle, you can see virtually, and using that magic wand, you can draw on the air and create that kind of geometry, okay? The bricks, that is virtual bricks. You can stack them, make some geometry so that you can create different shapes. Pedal, this is tabletop, and some virtually generated graphics will help you to create 3D geometry and so on. A lot of something future interface is under research and development. How about another one example, laser scan. You may know laser scan. I'll show you some video and example demos. Take a look at this laser scan. Simply that laser scanner has kind of laser beams and scan the 3D object, and you can get points. Thousands, millions, sometimes billions of points, okay? Each one of point has X, Y, Z coordinate system. In other words, all these grouped points, so-called point cloud, can generate 3D object very precisely for existing object or existing building. Look at one example video. First example is sort of advertisement. One of the famous company 3D scanner, Faro, their advertisement video. The reason I like to show you this one is it's very easy to figure out this 3D laser scan. Let's take a look at this one.
Taking the world from 2D to 3D, Faro is a global technology company that develops portable 3D measurement and imaging solutions. Faro's commitment extends well beyond product performance and constant innovation. With Faro, you have 3D measurement peace of mind. The Faro Laser Scanner Focus 3D is a high-speed 3D scanner for the detailed measurement and documentation of large objects, spaces and buildings. With a range of up to 120 meters, the Focus 3D creates photorealistic, three-dimensional images of reality. Thanks to its intuitive control concept with a touchscreen display, it's as easy to operate as a digital camera. The rotating laser of the scanner touches, in the truest sense of the word, its surroundings. The laser beam is used to measure the distance to the object and, together with the device's 2 rotation angle data, determines the coordinates in space. Several million of these 3D coordinates result in a complete 3-dimensional impression of its surroundings. Color scans are produced with the help of the integrated digital camera. The scan data is saved on the internal SD card, making it very user-friendly to transfer the data to a computer. Faro's Scene software automatically combines individual scans with the aid of integrated sensors in the Focus 3D, such as dual-axis compensator, height sensor, and compass, to create a cohesive point cloud.
The building industry is primarily developing towards the renovation of existing buildings, for which plans and drawings need to be prepared. For this, laser scanning is the perfect tool.
Data acquisition by means of 3D laser scanning is faster and more reliable than conventional documentation methods. Whether for 3-dimensional building documentation, monument preservation, or forensic crime scene documentation, thanks to its simple operation and compact design, the Laser Scanner Focus 3D is ideally suited for a variety of applications. Reichenbach Architects in Hanover offers scanning services aided by professional hardware and software supplied by Faro. As a result of the innovative possibilities of 3D laser scanning, the market is expected to grow enormously in the future.
Laser Scanning der Markt in Zukunft enorm wachsen wird.
focus is on simplifying our customers' work with tools like the laser scanner that empower them to obtain data more quickly, easily, and with less cost than ever before. Today, more than 10,000 customers worldwide trust and work successfully with various Faro solutions, making Faro the leading three-dimensional measurement and imaging company. Faro.
Okay, let me finish the video. Okay, this one is very powerful when you are using for existing building, interior, exterior, whatever, okay? So when you remodel this building, we need to get geometry. We can reuse AutoCAD floor plan files, or you can measure the length, height, thickness, and so on by using your physical devices. But this one resolves entire problem at once, okay? So what if this is actually standing alone, fixed scanner. What if you are handling this one by your walk or even in movable vehicles? This example shows you that actual video of point cloud. Okay, holding that laser scanner, and this is actually the CCA, College of Art, California, at San Francisco. In front of this building, holding that laser scanner, and all these are point cloud, and moving and passing by this school, and getting out of the door and turning back to see the building. They are not just image or some visual representation. All these are 3D point cloud, okay? Something coarse and roughly generated, but all these points have their 3D coordinate system, okay? So this is one example of that thing. And we brought this one. This is the first floor of this building, and we tried to scan the first floor and this room. So the picture took last year, and in front of that door, we placed that laser scanner, and we scanned this room. So, okay, the brand of this laser scanner is Leica, one of the famous DSLR camera brand. Actually, not DSLR, just very and world famous brand of film camera. But anyway, Leica, $100,000 price, Iraq. So bring this one here, and we scanned first floor and this floor, this room. So this is first example. You may find out this ATM machine and the pillar and the elevator hall, the stairwell, and some couches on the first floor. And when you data acquisition, we made a position at the center of that lobby. But actually, this is why we can see very different view. We can change camera because they are 3D point clouds. So some different view, and this is outside view of that first floor, this building. If we change the camera of that lobby, you may find out some tables and couches and a pillar and the ceiling structure of this building, first floor. But take a look at this white area. They are empty because at that time, laser scanner was here. They are not visible from that laser scan. So we need to place 2 or even from places and then combine them so that we can generate almost perfect 3D geometry. And there are huge glasses. So external trees or buildings can be captured, but at that time we ignored. Okay, we have laser scan. All point clouds can be collected, but actually no need to use that kind of laser scan device. We can reuse pictures So when I was in Autodesk 2011 at San Francisco, at that place, at Autodesk Gallery, there are amount of DSLR camera, digital camera. When I sitting in this chair and take pictures just 1 second, and then I can get this kind of 3D, actual 3D, okay, by using this one. At that time, this was prototype software. But nowadays, there is an app named Autodesk 1-3D Catch. You may know this application on your iPhone or Android. You can search and download. So let's take a look at this software, how it works. And just for your information, you may know this app, but anyway, let me open this one. Take a look at this video. Okay, this is 1-3D Catch. Based on the image, you can reconstruct this kind of 3D with very realistic mapping, okay? Image-based 3D generation. You don't need to geometrically model this one using 3D Max and take picture and texture map to wrap this object. You don't need to in the future or just now. Okay, another example. As you know, Google scanned our entire Earth and took pictures by using motor vehicles. You know Google Earth maps. They scanned the entire world, the entire Earth. You can see very detailed pyramid, really far from here. But anyway, you can take a look at street view of New York, San Francisco, Chicago, Europe, anywhere. According to your major, you're supposed to take pictures and try to make 3D objects when you get Rome. There is a Colosseum, so-called. Just taking pictures, taking your pictures with the Colosseum, selfie, and posting it on Facebook. That's exactly the same other people do. But reflecting your major, you need to do something such as image-based reconstruction and so on, so that you can reuse that your own generated 3D object to your design or something else. Anyway, Google scanned the entire world. What's the next target? of Google. What's the next target of Google? They did something building exterior. Nowadays, they're gonna get into the building, okay? Building interior. They are very interested in building inside. Of course, Apple or very world-leading large-scale companies are very interested in building interior, inside of the building. So without visiting, someone have to make geometry, but they don't need to. It's very time consuming and very expensive and almost not possible because design going to be changed kind of monthly base, yearly base. But take a look at this Tango project using smartphone, very specialized smartphone. Your smartphone has camera, flash, gyroscope, and some more sensors, but this one has depth sensor. Depth sensor calculates the distance when you take pictures, okay? And then they can generate 3D of interior, building inside. Building exterior, of course, taking pictures, that's it. Interior, we can get geometry. Append information on top of that geometry is the next topic. Go look at the last video for this one, okay? Project Tango.
My name is Johnny Lee, and I work in the Advanced Technology and Projects Group at Google. Our small team here, based in California, has been working with universities, labs, and industrial partners to harvest the last 10 years of research in robotics and computer vision to concentrate that technology into a very unique mobile phone. We are physical beings that live in a 3D world, yet mobile devices today assume that the physical world ends at the boundaries of the screen. Our goal is to give mobile devices a human-scale understanding of space and motion.
This is going to allow people to interact with their environment in just a fundamentally different way. We can prototype in a couple of hours something that would take us months or even years before because we didn't have this technology available.
What happens if you have all these pieces in a phone? How does that change what a phone is?
We have created a prototype phone containing highly customized hardware and software designed to allow the phone to track its motion in full 3D, real time as you hold it. These sensors make over 250,000 3D measurements every single second, updating the position and rotation of the phone, fusing this information into a single 3D model of the environment.
We have a problem called navigation doors, and it's a solution to that problem.
It tracks your position as you go around the world, and it also makes a map of that.
Imagine that you scan a small section of your living room and then are able to generate a little game world in it. I don't know of any other controller or gaming device that can do that anymore.
Putting all this together, they pulled in experts from all around the world and got them all working on the same project.
Rule about very high caliber computer. Why? It's very simple. I think that people believe that localization mapping is there on your phone and you just use it. It's this ability to follow in other people's footsteps.
And we can also benefit from what we do for the project back for the open source community.
Use it for visual impaired, give them or use or where they're going.
Being able to map your own, check out UCI dispersions or
Virtual windows to see different worlds. I mean, the possibilities are really endless.
Over the next few months, we will be distributing dev kits to software developers to develop applications and algorithms on top of this platform. We are just in the beginning, and we know there's a lot more work to do, but we are excited about where this is going to go. The future is awesome, and we believe we can build it faster together.
Okay, as you see, any building's interior geometry in 3D can be collected by using this kind of indoor movable devices, okay? Human can hold this kind of smartphone in the future and collecting environment and automatically upload it on the server, and then we can generate entire scene in history. Okay, 2015, this building, to 2015 January of this building can be stacked, stored. In 10 years from now, you can review this building interior exactly in 3D geometry through this kind of server, okay? You can retrieve your street view by using Google History, not current scene. 3 years ago, you can take a look at New York's 3 years ago from now. You can see that specific time. This kind of data can be collected by actual 3D and real pictures, not just point cloud or just simple 2D pictures. Anyway, this is one way of handling interior, exterior buildings, but as an interior architecture designer, interior designer, an architect, we need to take certain following this kind of technology trend and the changes. We need to understand behind the technologies. That's what I'm talking about, as always. My point is there, not user interface issues, okay? If you learn user interfaces, how to click, how to access, how to create box shape, what if your software version upgraded? Something different user interface. You have to learn again and again. But if you know ray tracing, global illumination, bump map, UV mapping, polygon mesh, and you know segments and the meaning of segment, how to control number of segments and how it works, what is sweeping, lathing, and then you can do same thing in SketchUp, Lino, Blender, whatever. Also, you use camera every day for taking your face and posting on the Facebook, your food every day, but you don't know mechanism, you don't know focal distance, aperture, exposure. You have to know detail because the camera in 3D Max or other different type of 3D graphics, the mechanism of camera is exactly the same to the camera in real world, okay? So if you can control the camera and your different lenses, and then you can apply that technique on your 3D graphics rendering, okay? That is why we need to learn camera behind the technologies. Without understanding those things behind the technologies, learning 3D Max or learning SketchUp, learning Rhino is equivalent to memorizing the order of clicking buttons, following your manual. If your interface changed, you have to learn again and again. Very messy GUI interface. If you understand the logic rather than the order of clicking buttons, you can learn any complicated modern 3D modeling and rendering software. So today's topic is actually 3D geometric modeling. So I like to bring your attention to geometric modeling issue as well as rendering too. But today's lab exercise, most of them are rendering. But anyway, they are supposed to be something else, and then you can render it. So how to create 3D model? That's the topic, okay? Geometry for making 3D objects. In this sequence, at the end, you create a box. This simple box shape consists of amount of sub-component in terms of 3D geometry. This box has edges, faces, polygons. The terminology is here. Vertices, edges, faces, polygons, surfaces. They can be simplified in this diagram like that way. In 3D graphics, anyhow, you have to create something like this, even if it's simple, and you have to modify this geometry. How to modify? What to modify? Subcomponents, okay? Not just controlling this one. You can control this box, but actually we can control vertex, edge, border, polygon, element. All they are subcomponents of this box. In SketchUp, we usually control the polygons using push-pull or edges. But in 3D Max, we can precisely control all the vertices, okay? All the edges, all the polygons, using this one, editable poly. That's one famous and very powerful feature, one of the features, powerful features of 3D Max, editable poly, okay? We're gonna learn this one for modifying the geometry. Okay, this one is simple box. What if this box height is 10 meter and 5 meter, 10 meter? This is building, okay? If you modify this one, modify this geometry very carefully, very long time probably, and then you can convert this box into this building, okay? That's the way of making 3D geometry using series of subcomponent and 2D objects. Okay, let's take a look at how to create 3D object, how to create 3D objects. Let me list up the methods to create 3D geometry. But this is number 0, not number 1, okay? Because they are some predefined object, making primitives. Box, cone, plane, sphere, cylinder, donut, all these objects are predefined primitives. How about this one? I told you this teapot is kind of homage to early developer of computer graphics, such as Martin Newell. He was living in near Utah area. In that place, this kind of Utah teapot is very common. So that is why he tried to make this one into his computer model, programming level in 60s, okay? That is why this icon is render icon. He tried to render this one in 3D computer, in computational manner. So this is why 3D Max render icon is teapot or render setup, or this one is one of the primitive, okay? You can model this one easily by clicking teapot on the primitive. So they are all primitive, including this teapot. So creating one of them and modify them into your own object. What if you want to create dome structure to make this kind of sphere and cut half and place on top of box shape, and then that's kind of dome-like object, okay? So in 3D Max interface, standard primitives, extended primitives, and amount of modifiers to modify that primitive, to convert them anything else, okay? From the box, you can create anything else, but you need to create something similar to your final product. If you want to create your own designed pillar, column in round shape, this one can be your first primitive, not that box or sphere. This is all of them are primitives. 3 spheres, 1 teapot, and 1 plane, but I assigned Autodesk material. And just 4 Mantalay lights. And then we can generate this kind of picture quickly in just 5 minutes, okay? Just simple modification so that prove that this is computer graphics, not actual. Okay, how to make 3D object using 2D. We are using 2D interface, okay? Your 2D screen, your 2D mouse interaction, and so on. So the first way is extrusion, extruding a polygon. You know SketchUp, push-pull tool, very simplified. You need to make some profile, all these are profile, and then you can put some z-axis value, thickness, length, and then finally we can get this kind of 3D object, okay? That's the first way of creating 3D object. Actually, there are very few ways of creating 3D objects. This is the first one. The second one is revolving surface. The term lathe is the term of 3D Max. Okay, in 3D you can find out lathe using lathe modifier. You can create this kind of 3D object. What you need to do is draw your own profile, section profile, and axis. Revolve it, and then you can create 3D geometry. Actually, this one is very complicated geometry, but in terms of lathing, revolving surface shape is not that complicated, and the axis, well-defined axis, gonna generate this kind of 3D object. This is 3D Max interface. Okay. The third one is similar to revolving or some others, but two elements you have to define. The first one is section profile. Okay. The section profile along with a pass. So number 2, pass is another geometry. According to this pass, you can generate this type of 3D object. Section profile, circle, and this shape of pass will generate this kind of 3D object. Okay. If you control this pass or control the section profile, you may find out there are a bunch of different type of 3D shape can be generated. What others? First one, skinning, named in 3D Max, but this is so-called morphing. Okay, morphed by star shape, circle, and rectangle shape, following a path. So this one is looking like this object. So you can generate that kind of object using that specific function. Another one, Boolean operation. This one looks very complicated, but actually if this is solid model, we can use this kind of intersection, union, minus, and so on. So all they are primitives, okay? Box primitive, sphere primitive, cylinder primitive. 3 different primitives, but A plus B union, another plus generates this kind of thing. Box minus sphere gonna be this kind of shape, and another minus operation, so that you can generate this final product. Okay, this is kind of series of equations, series of operations, mathematical, algebra, certain type of algorithm. Okay, so-called constructive solid geometry. 3D Max has surface-based model features and solid model-based features. Even in SketchUp, you know the solid operators, solid tools. In solid tool, we can get some intersection, union, minus, something like that, operational geometric generation functions we can use. Actually, there are something possibly more, but not that many different ways by using your computer 3D software. By using any type of 3D software, most of 3D making approach are all same, only those things, okay? If you invent new thing by using 2D geometry, you're clicking mouse or something else, that's going to be really nice, because all day invented by someone, but nothing beyond this structure. Iterative modification based on this generation. Okay? But actually, another applications we can use, we can take advantages of more things. Simply, if you have AutoCAD file for your building design, you can import that CAD file and extrude this wall object, and then you can generate 3D building model. Another way, simply import 3D model, SketchUp model. You can easily drag and drop your SketchUp file on top of your 3D Max. and then you can take a look at almost same geometry to SketchUp. You can download 3D warehouse model in SketchUp format, .skp file directly into 3D Max, and you can reuse that geometry in 3D, not 2D, okay? So reuse is one good way. Another one is predefined, parametrically defined geometry. Okay, there is AEC extended. The term AEC here means architecture, engineering, construction, our domain. AEC extended objects are certain type of primitive like, but bunch of options. These are windows. The name windows in 3D Max. The wall object in 3D Max. Door object in 3D Max. What you need to do is define height, width, thickness and the border thickness, and so on, and material assignment, so that you can convert this geometry into your actual objects. You don't need to make everything by editing geometry. Anyway, they are something predefined, parametrically defined objects in current 3D Max, okay? We're gonna deal with this one later in this semester. This is one example of that. Take a look at these walls, windows, and chairs, even trees. The trees predefined in 3D Max. Simply drag and drop this tree in your 3D Max, and then you can generate this one. You can render this one, okay? How about this one? Looking very complicated. What if you have to model this one? Draw risers, steps, railings, one by one, probably taking long time. But simply click stairwell and put very complicated options and place it. But actually, later on, we're gonna make that kind of AEC extended columns, walls, windows. But controlling option is also not that easy, very complicated, but much faster and powerful than simple mere geometry-based modeling, okay? So that's the way of taking advantages of this kind of parametrically predefined geometry, especially in 3D Max, okay? Some parametric tools, Formzy, Rhino, by using plugins, we can take advantages of those predefined geometry. Anyway, we're gonna use 3D Max and we're gonna deal with this part later. Okay, let's get back to our fundamental issues. Learning 3D Max, learning 3D graphics. I told you we have to know some behind the technologies and mechanism rather than user interface issues. Not just interfaces of 3D Max design. We have to know mechanism, process. That's the best approach you can take. Let's take a look at what to do in 3D Max and other general 3D tools. What's major function? What are the things we can do? Very simple. I can categorize them just 3. First one, geometric modeling, to create your own object. Secondly, thirdly, actually they are same. Secondly, rendering, visualize your scenes, okay? Finalize your design representation. How about animation? Series of rendering, okay? 30 rendering scenes per second. So for 10 seconds, 300 rendering, just for 10 seconds, okay? So geometric modeling is usually very difficult and time consuming, very tedious. But anyhow, you have to do your geometric model because your design is something geometry. Of course, you have to assign material, lighting, and so on, but without geometry, you cannot do anything. So you need to create your own geometry for your design. Rendering, many things to take care of. But as you experienced Mentalei or some advanced features of 3D Max last week, 2 weeks ago, you realize that there are too many things, but thanks to predefined features and material, we can easily use that kind of advanced technologies. Animation, you need powerful computers, more memories, faster CPUs for your computers, okay? What you need to do for the classroom is taking number 1 or 2 computers, the fastest computers, much faster than mine, number 1 or 2, okay? The best 2 computers. Second computers, former side and the back side. You're gonna fail to finalize your render until midnight someday in 3D Max lab exercise, okay? So render time quite long, 2 hours for one scene sometimes. So you have to be proactive, okay? Number 1 or 2 computers. What are in geometric modeling? Create 2D geometry and 3D objects and import predefined 2D, 3D and manage them by editing lines, points, edges, editable polys again and again. Very, very time consuming, tedious, okay? That's the way of geometric modeling. That is why there are even advanced tools such as Revit. Revit is BIM tool. Next semester you're gonna learn Revit in my classroom, okay? That is so-called BIM tool, much advanced one, not this kind of geometry-based modeling. In Revit, you can model walls, floor, ceiling, column, windows, stairwell, instead of line, point, edges, polygons, and so on. You cannot model lines or polygons in Revit because Revit is dealing with building. In building, in reality, there is no line. Line is mathematical concept. In real world, there is no line, okay? Line like solid, very thin object. That is anyway 3D. In Revit, we can define that kind of real objects. No surface, no line. Surface means something visible, but thickness is 0 mathematically. But no such objects in our real world. That's very important difference. Anyway, geometry modeling for this semester, very time consuming you have to do for your design representation. For rendering, assigning material, add lights, artificial lights. Last week we have learned how to install skylight, sun. Today topic is artificial lighting, okay? And set up cameras. You're controlling views and amount of render options so that you can generate your own pictures. Let's take a look at 3D Max specific scenario. This is the most important slide today, okay? As an interior architecture designer, how to use 3D Max? Let's talk about that. Defining UOD first. The term UOD means universe of discourse. Your universe of discourse, okay? Now you are designing a table. Just imagine that situation. You are a table designer. For that table, you have to define your universe. You don't need to place Mickey Mouse, okay? You don't need to place something else except table and its related environment or objects. Okay, that's the focus. So, what's in your mind? You have to know that one first for your design representation. If you don't know what to do, don't open 3D Max, okay? Taking a lot of time. You have to roughly sketch by freehand or simply write down what to create. There is a table on a floor material gonna be wood, and your table gonna be rectangle shape, and there gonna be a base, and 3 lighting on the ceiling, and that's it. That's your universe, okay? Write down and try to make something exactly based on your idea. And if needed, update your universe. So defining UOD first, that's very important. And then create geometric models. What to create? Firstly, define your universe, your environment. If your environment, no need to install walls or ceiling, you don't need to install. Just single plane, huge plane, and then you can see your floor, bottom, okay? No need to define walls if you don't visualize walls. So defining environment first and model your design elements, your tables, your furniture. If your target is wall surface, you're supposed to model walls, okay? Your design elements. What are in the environment? Planes for your floor. Sometimes plane is enough. Walls, ceiling, bottom slab, columns, amount of architectural elements. Sky, outside view. That's why we installed Mantalay sun and sky. Also, amount of iterative modification in your environment modeling. How to model your design things. This is main objects for your design. 2D sketch and extrude, revolve to create 3D objects by using 2D sketch or something else, and import CAD file, import Rhino file, import FBX file as we did last week, import Sketcher file directly, and modification again and again. Very recursive and time consuming. And then you can create your own render scenes back and forth. When you fail to get the image what you want, you have to update your universe model, sometimes redefining your universe, and you have to take care of materials, lightings, camera, and rendering options, and so on. But comparatively, not that long time you need. But the problem is, this one takes time, and computer needs amount of time sometimes just for rendering. You don't need to do anything while computer is rendering. But sometimes it's very time consuming. So I'll let you know how to save render time, probably next time, next lab exercise. And sometimes you need retouch in 2D computer graphics tools such as Photoshop. Okay, blurring background, you can do that 3D Max the same way, but sometimes it takes 2 hours, but by using Photoshop, it takes only 1 minute. And then you can use Photoshop rather than using geometric modeling. But precisely controlling and modeling 3D objects or texture mapping on very complicated surface using Photoshop takes really long time or sometimes even not possible. In that case, you have to do that in 3D Max. You have to know what's the best way. So this is scenario. You have to know the mechanism and the flow when you are doing 3D modeling. If you don't have any plan, any of these mechanism or some flow, and then possibly you have to spend double time for doing your 3D model or 3D rendering, okay? Anyway, it takes time, so for your saving your time, your life, you have to plan your things first, okay? So sky, we installed. We placed the planes and we tried to make some rendering simply using sunlights and Autodesk predefined materials. And then you can create very easily some photorealistic rendering scenes. Again, another summary. Before modeling and rendering, defining your universe first. That's very important, okay? And roughly designed your universe supposed to be drawn by yourself, by freehand, or written down by yourself, so that you can clearly understand what you are doing. Most of you don't know what you are doing now. That is why it's very hard to do, okay? So define your universe world first, and then 3D geometric modeling. It's hard and time-consuming, tedious. But anyway, there are a couple of useful techniques we're going to deal with in the lab exercise. Rendering for making high quality and some good visual effects. There are also a bunch of series of techniques you have to know. We're going to deal with that in lab exercise, of course. And simple is better, less is more. So you need to know Photoshop. And then your final product, final image can dramatically improve by using that kind of software, okay? Sometimes engineers are very good at 3D graphics by programming or by using this kind of software. But final output is not that great compared to something done by designers, simply because designers know Photoshop, okay? So paradoxically, Photoshop experts always the winner. Okay, this is 3D Max interface, simplified version, older version. There is Cartesian coordinate system, X, Y, Z, but take a look at top view, front view, left view, all they are 2D, okay? 2D perspective view. This is actual 3D perspective view, but we need to take a look at those views at the same time. If you want to see this one enlarged, and then Alt-W, okay, toggle the view. But sometimes we have to use this top view. When we install artificial light, we have to use this top view. It's not easy to control here or front view and so on. Each view has its own pros and cons. View cube to control the views, workspace, steering wheel, but there are amount of hotkeys. I list up hotkeys. The hotkeys listed here, all they supposed to be memorized, okay? Viewing options, object handling options, utility. For example, if you want to move, you can click move icon, but it's not M, it's W, okay? Similar to M anyway. E, rotate, R, scale, H, select by name. You have to know the buttons, hotkeys, okay? Also, Alt, W, maximize toggle the viewport, and M, material editor, F10, render setup, Shift Q, rendering, okay? Bunch of hotkeys. Also, you can set up your own hotkeys. You can change hotkeys. But anyway, they are default hotkeys, something different from your computer by computer here. But anyway, you have to know very useful hotkeys first. And it's time to move to the lab exercises. I would like to move on to the lab exercise quickly for reviewing the lab exercises from the last week first. Okay,